Hey everyone, in today's video I'm going to go over the common compression tools that are available at your disposal on any Linux operating system. To get things started, I'm going to start off with gzip. Now gzip is probably the most common compression tool that you see used, and to use it it's fairly straightforward. There's really just one command, but what I want to do is I'm going to take this file, log file, and you can see here this is, I don't know what number that is. I can't even remember if it's in bytes or bits, but a cool little tip or trick that you can use to make it easier to read the size of a file is just do ls-l h. The H stands for human readable, so it gives us 136 kilobytes. So that's a little easier to read versus this number where you have to count how many digits are there. So we have this 136 kilobyte file, and it's just a plain text file, and we can compress it using the gzip command. So gzip, to use it, just do gzip and then the name of the file. So log file 1. And after we do that, if we do an ls-lh, you can see here it compressed the file and put it in a .gz format, and now it's only 13 kilobytes. So it significantly reduced the size of the file, which is great. That's ultimately what we want to do with any compression tool. Now we've compressed this file. Let's say we want to now decompress it. There's a few different ways to do that. The first way is just doing gzip and then passing in the D flag and then giving the file name. So we can do that. The other way to do it is instead of doing gzip-d, you can do gunzip. So it's basically saying g unzip, sort of. Just use whichever one you prefer. I usually just use gunzip. And after we do that, if we look at the file now, it's now back to the 136 kilobytes, and it's removed the .gz extension. So if you do run the gzip command, it will compress the file that you're trying to compress. But let's say we have a file that we want to copy and create a compressed version of the copy so that the original file remains intact. We can do that as well. And to do that, all you have to do is gzip, then provide the -c flag, then the name of the file that we want to compress, and then pipe it. And now we want to create a copy, and let's name whatever we want the compressed file to be named. So we'll just call this log file underscore compressed.gz. So this is going to take this log file 1, create a copy, compress that copied file, and then store it in this file's name. So after we do that, if we do an ls-lh, we have the compressed copy of the file, but we also keep the original file. And we can do the same thing when we're uncompressing a file, where we can keep the original compressed file but create a copy and uncompress that. To do that, we just do gzip -c again, and then we also throw in the -d flag because we're decompressing, and then provide the name of the compressed file that we want to create a copy of. So that's log file compressed.gz, and then provide the name of the file we want the copied file to be, and we'll just say, we'll call this log file 2. And if we do an ls-lh, you can see here we still have the original compressed file, and then we have the copied file that we decompressed. Now, when you have a compressed file, you can get a little more detail from the file by doing a gzip -l and then the name of the file. So this gives you, whatever. I don't know how to read that, to be honest. I guess this is the compression ratio. It's just a little bit more detail about the compressed file. I just figured I'd let you guys know about that. And so we've covered how to compress, decompress. Let's say we want to read the contents of a compressed file. Remember, to read a file, you can just do cat and then name the file. So if we try to do log file underscore compressed, let's see what happens. See, it gives us this jarbled mess, and that's because the file is compressed. So to read the compressed file, we actually have a few special commands to use. The first way to read a compressed file is to do gunzip -c, and then the file name. What did I call it? logfile_compress.gz. So this looks like we're trying to decompress it, but instead we're going to put the pipe symbol and then less. So this will allow us to, space through the file and read it like any other text file. And you can press Q to exit out. The other way to read a compressed file is to use a utility called zcat. So you just type in zcat and then the file name. So that's going to be logfile_compress.gz. And it basically does the same thing as the cat command, but it works on compressed files. So feel free to use either one of those tools to read compressed files so that you don't have to decompress it and then read it and then either delete or recompress the file, because that's a bit tedious. Now, when you compress a file, you can actually adjust the compression optimization by passing in a specific number into the gzip command. By default, the number that gets passed in when you run gzip is actually the number 6. And we can put it in any number from 1 through 9, with 1 representing the fastest compression, but it will provide the least amount of compression, versus 9, which will do the most amount of compression, but will take the longest amount of time. So by default, Linux uses 6, which is a good balance between the two. But let's say we have a really, really, really large file and we want to make sure we compress this as much as possible. We want to use the 9. We want to provide the input of 9 to make sure that we compress it as much as possible. So to do that, let's look at the files that we have on hand. And let's say we have log file 1, okay? And let's say we want to compress that to the absolute max. What we can do is do gzip, then provide the number, which is going to determine how much compression we want. So in this case, we want to compress it as much as possible. So we're going to do -9. And remember, this is also going to be the slowest method because it has to do the most amount of compression. And let's give it the file name. And remember, so log file 1 and log file 2 are the same exact file. So I'm going to show you an example with the -9 on log file 1, and then we'll go back to log file 2 and do it with the -1, and we'll see the difference. So here, once we hit enter, we do an ls-lh. We can see here it's 13 kilobytes. And if we do the same command, but instead do this on 2 and provide it with a compression optimization of 1, that means we're going to prefer speed over the amount of compression. So this won't compress it as much, but it will perform at a faster speed. Now, for the file size of 136 kilobytes, doesn't really matter. We're not going to notice the difference. But if you've got, gigabytes and gigabytes of text files, those will see a difference in speed between the two different ratio numbers. So if we do that and then ls-lh, you could see here the one that was provided with a compression optimization of 1, it's slightly bigger because the file doesn't get compressed as well, but it gets compressed at a faster speed. So that's how you use the different numbers to provide how much compression you want to actually perform. The final thing with gzip that I want to cover is, let's see what happens when we try to compress a directory. Let's say we want to, let's actually create a new directory, okay? So let's do mkdir, and we'll call this folder compression. So now we have the compression directory, and let's cd into that. And let's just create a few files. 1, 2, 3, and then if we do an ls-l, they're all empty files. So when we try to actually compress them, it's not actually going to save us space, but I just want to show you how we compress directories. Sorry guys, I accidentally closed that out. So we have the compression directory. And let's say we want to compress the directory and all of its contents within it. If we try to do gzip and then compression, you can see gzip throws an error saying this is a directory and we can't compress that. So, we've seen that anytime we want to run a command but on a directory, there's usually a special flag, usually the -R, to perform that specific command on a directory. But to make sure that's an option for us, let's do gzip --help, and let's see what options we have. And we do have a -R for recursive, so this will perform this recursively on directories. So let's try that. We do gzip -R compression, and let's see what happens. You can see that we still just have a regular directory, okay? And it's not a .gz file. It doesn't look to be compressed. If we cd into compression, and we do an ls-lh, you could see that the files within it got compressed. And that's the thing I wanted to show you guys, is that when you do gzip with the -R flag on a directory, it doesn't actually compress the whole directory. It compresses each individual file within the directory, and that's what it did here. And I really wanted to highlight this behavior because later on in this video, I'm going to show you how we actually, make backups and compress directories. We have a special tool for that, and it's called Tar. And Tar can actually be used in conjunction with other compression tools like gzip, so that we can take snapshots of directories or our whole file system and then compress it, so we have small backups of whatever directory or file system that we want to back up. So gzip isn't really good for backing up entire directories. It's better for compressing individual files. But I will explain how Tar works at the end of this video. So we've finished everything I wanted to discuss with regards to gzip. The other compression tool that we have is called Bzip. And the way Bzip works is, it's a different compression algorithm altogether. I don't know which one's better. You can do a Google search to see which one's better for, what type of file and whatnot. But the way we use Bzip, it's pretty much exactly the same as gzip. So if you learn the commands for gzip, you've pretty much already learned the commands for Bzip. But I'll go ahead and do a few examples for you guys. I'm just unzipping these files so that we can then rezip them using Bzip. All right, so we've got these two files. To compress using Bzip, we just type in Bzip 2 and then the file name. So in this case, log file 1. And if we do ls-lh, you can see we've compressed that file. And you'll find that every single command you use with Bzip is the same as gzip, but you just replace gzip with Bzip 2. That's it. So to compress a file, it's Bzip 2, then the file name. To decompress it, we have two options, just like we did with gzip. You can do Bzip 2-d and then the file name, or you can do bunzip 2 file name. Oh, you didn't need the -d in this case. You would just put it in like that, or you can do Bzip 2-d. So whichever one you prefer, they both do the same exact thing. And you can see here we've uncompressed the file now. And we can also do the same thing with copying and compression. We can copy the file and compress the copy of the file. To do that, it's Bzip 2-c, then the file name, and then redirect that to a new file, and we'll call this log file 1 copy.bz2. So now we have log file 1 and the copy of it. To read the contents of a specific zipped file, if you remember with gzip, we couldn't just do a cat. We can't open it up in VI, so we have to use a special tool if we want to read a compressed file without having to uncompress it first. And we had a tool called zcat for gzip, well, we have another tool called bzcat, and it's just bzcat, and then the file name, and that'll do the same thing that zcat did, but for bz2 files. Okay, that's all I wanted to show you guys with bzip. All the rules that applied for gzip apply to bzip. So if we try to compress a directory with bzip, remember, it's not going to actually compress the directory, it's going to compress the files within the directory. Now, while gzip and bzip are useful, most often you'll see them paired with the tar command to compress archives of files. And the tar command stands for tape archive, which is used for creating compressed archive files that can be easily moved from disk to disk or from machine to machine. It's an excellent tool for creating backups, and one of the extra benefits that comes with using tar is that it preserves the directory structure, and it also preserves things like permissions. And that's something that gzip and bzip don't seem to do. Okay, so to create a tar of a directory or any folder that you want, the command to do that is tar czvf and the file name that you want to create for the tar file, and then the directory that you actually want to create a tar of or a backup of. Okay, so as an example, I'm going to create a directory called compression, and we'll cd into that and just create a few random files. File 1, file 2, whoops, type. Okay, so we have 3 files inside this directory, and let's say we want to now create a backup of that directory. To do that using tar, we just do tar czvf, and you'll notice that with the tar command we don't actually need the dash before our flags. We can just put in the letters that we want. And to go over what each of these letters means, C means create, so we're creating a tar file. Z means we're going to not only create the file, we're also going to compress it using gzip. So we actually don't need the Z if we don't want to compress. And as an example, I'm going to leave it off actually for the first time, just so I can show you an example with and without the Z flag. V stands for verbose, so when it actually creates the tar file, it's going to go and print out on the command line the different files it's compressing. And then F means that we're going to provide the file name of the tar that we're creating. So because we put the F flag in, we have to provide the command the name of the file for our tar file. So in this case, I'm just going to call it compression_backup.tar. And then now we have to provide the directory or folder that we want to actually take a backup of. So that's going to be the compression directory. And you can see here, it spits out the different files that were compressed, and that's because of the V flag. And if we do an ls-l, you can see that it created a backup. Now, if we do the same command, but this time we'll call this .gz because we're going to compress it, we can then put the Z flag in. So the Z flag means that not only are we going to create the tar file, we're also going to compress it using gzip specifically. We can run that. And you can see here that this file, or this tar file, is significantly smaller than the first backup because it's compressed using .gz. So that's how you take a backup. Now let's say that once the file's created, you want to peek inside and take a look at all the different files that are within it. So let's take a look at this one, the uncompressed one first. So to look within a tar file, just do tar and then tvf instead of cvf, and then the name of the file. And it's going to spit out the contents of it. If we try to do that for the .gz, it'll also work. But usually, I see the examples always put the Z for the compressed option. but it seems to work even if you don't have the Z. But basically the T flag is going to allow you to read the contents of a tar file. So now that we've shown you how to create and read the contents of a tar file, let's look at how we decompress and expand a tar file. And before we do that, I just want to make a few modifications. So let's go to the actual compression folder, the one that wasn't, the one that we backed up. And I'm going to just go into one of these files. And I'm going to just type some random text. And we'll save that. Okay, so we've actually made a change since we last took a backup. So file 1 is different. So if we go back to my home directory and we want to expand and uncompress this backup, we just type in the command tar and then we press the X flag. So instead of C or T, we provide the X flag to expand, and then ZVF, and then the name of the file. So it's going to be compression backup .tar.gz, and it expanded all the contents of our tar file. So if you look at our directory, it looks exactly the same, but if we go into the compression folder, it still looks the same, but if we cat the file, you notice how file 1 has nothing in it. And that's because the change that we made, because we uncompressed this, it then rewrote over the original file 1, which had those extra text, and it replaced it with the empty files. So that's how you can actually use these as backups. Is all you have to do is just uncompress them in the same directory, and it's going to rewrite all the files with the files that it had. We can also move the backup. If we move up of directory, and we can just move the backup to, and we can change it to /temp. If we go to /temp, we have our backup file, and we can expand it within the temp folder. So you don't have to just decompress and expand the file within the same directory that you had originally taken it from. You can do it anywhere. So I can copy this file to any other PC and decompress and expand the entire tar file. So now if we do an ls-l, we have our compression folder, and within it, it's an exact copy of what we had originally copied. Now, I showed you how to use the tar command with the gzip utility so that we compress the tar file when we pass in the Z flag. But if you remember, we have another compression tool, and that's Bzip. And we can create a tar file and then zip it using Bzip as well. And the command is pretty much exactly the same. We just have to provide it one slightly different flag. So let's go back to my home directory. And let's take another backup of the compression folder. But this time we're going to compress it using Bzip. To do that, just do tar. And then we do C to create a tar file. And instead of Z to compress with gzip, we want to pass the letter in J, and that means we're going to compress with Bzip. And then we can do the same other two flags that we always provide, which is V for verbose and then file, and we'll call this compression _ backup .tar .bz2, and then the name of the directory we want to take a backup of, which is compression. And after we do that, if we do an ls-l, you can see here we've now created a backup and compressed it using Bzip. And to extract or look at the contents of this compressed backup using Bzip, It's the same exact thing that we did with gzip, but you always just replace the letter Z with the J. So if we want to look inside of it, just do tar, and then we do T to read the contents, and then we do J instead of Z because we're using Bzip now, and then we do VF and then the name of the file. And if we want to uncompress and expand the archive, we just do tar and then xjvf and then the name of the file. All right, there you go. So that's the basics of how to create backups using tar as well as compress them. Now, I told you guys that the tar command will allow you to take a backup and save the permissions of the files. And by default, tar actually doesn't do that. We actually have to provide it a parameter or an option to specifically preserve the permissions. So if we remember the command to actually create a tar file, let me see if I can find it in my history. Here we go, tar czvf. All right, it's the same exact command, but we have to pass in the P flag. So when you pass the P flag, it's telling tar to actually preserve the permissions of all the files within the directory. So we'll just rename this with permissions. And now the tar file has saved all the permissions of the 3 files that are in the directory. If we want to then extract and recover that directory, it's going to be the same exact command as well, except we're going to add the P flag again. So it's going to be tar xp zvf and then the compression underscore backup. So that will maintain all the permissions, and I feel like for the most part that's something you want to do, but you do have the option of either keeping the permissions or just forgetting about them. It's ultimately up to you whether you want to save them or not.